I'm James Johnson, and you're watching Niagara Pro Tips. Welcome back. This is the first video in a multi-part series on BQL. This should cover everything you ever wanted to know about BQL but were afraid to ask. I'll break this up into multiple videos just to make the content a little bit more digestible. To start off with, we'll use a PowerPoint and cover some of the key points, and then I'll go back and forth between the PowerPoint and the Workbench client. So the Baja Query Language, or BQL for short, is an SQL-like language. And SQL is structured query language. That's a language that's used for querying relational databases and doing data manipulation. BQL is a little bit more limited than SQL is in the stance that it only supports a select statement. So that allows us to query data from either station components, the alarm database, or the history database. There's also a few important concepts to understand. First of all, resolving a BQL query or an ORD against a station doesn't subscribe anything in the station, meaning it won't cause a driver to pull the data points, the control points under the driver, for example. It's just going to report the last known values in the station. Now, there are some components that do utilize BQL, for example, a BQL grid or a component grid, or maybe min-max average BQL from Vicom Pro. And those components will use BQL to find things, but then they do cause subscription, which will cause drivers to pull and things to update. Most of the help topics related to BQL can be found in the Doc Developer help topic, and I'll show you where that is in a few moments in the help. In the Niagara framework, we have something that's referred to as component types, and this indicates the type spec of the component. And a type spec is made up of two pieces of information, the module name and the type name. And the type name is the same as the Java class name, with the exception of dropping the leading B character. There's a couple of different ways that we can figure out what the type spec or type is of a component in the station. One way is to take a look at the AX slot sheet of the parent component. And you can see on the screen capture here that the slot sheet shows us the type as well as the name and the display name. Another way that you can find out the type of a component is typically to right-click the component and then from the Views menu, select the Baja Doc Help, which will take you to the Java documentation. That will show the class name as well as the package and module which that component comes from. Take a look at that here in the help as well in just a moment. Within Java, there's a concept of inheritance. And software developers try to write code in a modular way. So in this example, you can see kind of on the left-hand side is a capture of some of the Java documentation for something called a B control point Java class. And this comes from the control module. So that would be a control : control point is the type for it. That defines the general behavior for all control points. So you'll notice that there's a property called facets and a proxy extension. All control points have those two properties in common. So the developer created that Java class that defined that behavior. You'll see the subclasses expanded there, and underneath you'll see things like discrete points, and which make up Boolean and enum points, or numeric points and string points. Those are more specific implementations of the general or abstract control point class. On the right-hand side, you'll see the numeric point then has a property which defines the out slot as a status numeric. The numeric point still has the facets and proxy extension property that were defined in that superclass. So the extended class or the subclass will inherit all the properties and all the Java API methods from the superclass, and that's just an important concept to understand. We'll come back and focus on this again later in this video and later in the series as well. Now, there's lots of courses online or books that you can read and learn more about Java, which I definitely suggest because that's a very important piece to understanding the cool things that you can do server-side in a station. And just at a very high level, talking about what Java methods are, these are the APIs or the software methods that can be called. When you look at a Java method, it has a signature to it, meaning what kind of parameters are required, how accessible it is, what does it return, and so forth. So I've highlighted here with colors that you'll see the modifier is the first term in red, that's going to either be public, private, or protected. And it really just indicates who can call that software method through source code. One of the next items that you'll see, and sometimes there may be another keyword like final or static, but one of the next things you'll see on the method signature is the return type in blue. This tells us if the method actually returns an answer when it gets called. If you see the word void there, that means that it doesn't provide an answer when you call that method. In this case, double is a type of number saying when I call this calculate method, it should return a double value to me. In green is going to be the method name, and that's what we're going to be looking for to use in our BQL syntaxes. And then in parentheses in purple there may or may not be parameters listed, and these might be inputs that are required when that Java API method is being called. So in this case, it's saying whoever calls this calculate method needs to provide two different double values, and those double values will then be used in the source code to come up with some response, in this case, an answer by summing the two values together and returning that double value. What you see in the method body in between the curly braces, you won't see that in the help, but I'm just showing it here as an example that there is some source code behind this Java method. So let's take a look at some of that real quickly in the help. Looking at the station, if I navigate into the station and go to one of my air handler devices under the BACnet network, I can right-click on a control point, for example, and go to Views and Baja Doc Help. When I select Baja Doc Help, that will open up the help documentation and take me to that Java documentation. So I can see this particular component is a B numeric writable class, and it comes from the control module. We can also see that it extends numeric point here. So this is telling me the superclass that this comes from. It also shows me subclasses of the numeric writable, meaning things that implement more specific behavior. You can click on this B numeric point link, and that will take me to the superclass where I can see the slots that are defined. So numeric point actually defines the out slot, and numeric point has different types of subclasses, one of which happen to be that numeric writable. And the numeric point extends B control point. This is where it actually defines, the source code defines the facets in the proxy extension that you'll find on all control points. So it's very important to understand the concepts of the class hierarchy and the inheritance. That's one of the key concepts that's critical here. When we're looking at any of these Java documentation here, we'll see that in addition to defining the properties and the subclasses, there'll be a list of API methods. And these are the methods that I was just explaining very basically, and we're going to dig more into those over time here. But you'll see that there's methods which are public that return something like bFacets, and the name of the method is getFacets. So this tells me this will return the facets that are applied against the out property. So we're going to be looking for methods that are public that give us some kind of an answer back when we're looking for Java API methods that we can use with BQL. When you see the word void, like in this case, public void, then this means that it doesn't provide an answer when that API method gets called. So that's just a little bit of information to look out for there. Going back to the station, we can also take a look at the AX slot sheet of the parent points container. And here we'll see that for these points as well, we can see their type, control module, numeric writable, or control Boolean point, and so forth. We can also see the name and the display name of those components. All right, now we'll go back to our PowerPoint. We want to talk a little bit about the BQL language itself. And this might look a little bit intimidating to start with, but we're going to break this down over the course of several videos, and we're going to talk about all the details about each of these portions of the BQL select statement. But for the time being, just understand that the BQL ORD, the select statement, it has a base ORD to it, which provides some scope to limit where in the station that we're going to be processing this BQL query against. And then the select statement is made up of a bunch of clauses. There's a projection, which is in red, And that specifies the information that we want to see. So think about an overhead projector or a screen, right? The projection is what we want to see in the results. So that's a comma separated list of the things we want to see. The extent is in orange. That's the from clause in the select statement. And that helps us define what we want to report on or query against in the station or the alarm database or the history database. The predicate in green, it has the where clause there. And the predicate is a Boolean expression that helps us filter things out of the result set when we search based on the extent in the base ORD. We also have a having clause, and that's a Boolean expression that's based on aggregate functions that can also be helpful for filtering things out. The order by clause is used to sort those results in either ascending or descending order. And there's a group by, although not explicitly supported as a clause, we do apply implicit grouping, and we'll talk more about that in a subsequent video. Now, a lot of you, I'm sure, are familiar with using the BQL query builder. And this is the user interface that pops up when you're doing things like maybe point discoveries, using a BQL grid or a component grid, working with bound tables in a PX view, or maybe using the batch editor to manipulate things in the station. The query builder does provide a user interface and allows us to do some of the things with BQL, but it's not all inclusive. And I'm trying to highlight here in this example that out of that whole BQL select statement, you can see in the query builder under the find section to the left, highlighted with the blue box, that's where we specify the base ORD. On the right-hand side with the orange box is where we specify the extent, meaning what we're looking for. Under the choose section in the middle, where it's highlighted with a red box, that's where the projection is configured. That's saying what do we want to see in our results. And then under the match section, we'll see that that's where the predicate is handled. Notice that there's no support for the having, order by, or group by within the BQL query builder. We'll also see that there's some other limitations that might require us to simply type in through a command line essentially, or an ORD field editor, what we want our BQL query to do. Now, with BQL language, there's different ways that you can make references to variables, and these would be referred to as literals. So when we talk about primitives like Booleans, strings, and numbers as being primitive type objects, then all you have to do is for strings, you're going to enter those as single quotes, like system admin here with single quotes around it. For a number, integer, a float, or a double or something, it's just going to be the numeric value without any quotes. And then for Boolean values, we have true or false keywords, and those are unquoted. So if you put single quotes around them, they would be evaluated as a string. So keyword true or false. There's also going to be times when we need to compare something to an enum tag value or to some other kind of component in the station, which is maybe a B-simple type object. For enums, what you're going to do is you're going to use the type spec of the enum and then with a dot character and then the tag that you want to test for. So in this case, alarm state dot off normal. And you can see with the enum field editor selector in the top right corner, just trying to show you what those tag names actually are. So you're not using the ordinal values, rather you're using the tag names from the enum range. B-simples are very similar to that. You're going to use the type spec, and then instead of using a dot and say a tag, you'll have a space, and then in single quotes, you're going to put the string, and it's going to be based on the encode to string or decode from string really method that the framework uses. So how does it create one of these based on a string value? The capture here is showing the encode to string method from the BREL time help document. And you can see it just says write the simple in a text format as the number of milliseconds. So by saying Baja (rel time) and then the 30,000, that's saying 30 seconds, right? 30 number of milliseconds, 30,000. So divide by 1,000 is 30 seconds, right? Take a quick look at the help again, and I'll show you what I mean about the B-simples. So in the Workbench help, you can go to search and find Baja Doc, or the shortcut for that is Control F1. and that comes up with the Find Baja Doc, and you can type in the class that you want to search for. Now, this is case sensitive here, so you do need to make sure that you have the spelling and the capitalization correct, or you could use the search over here, in which case it's not case sensitive, and it will find things on partial matches and so forth. But you would be looking for the type of document, which is our Baja document. It might be a binocular icon if you're using the zebra theme. This is the lucid theme, so it's the question mark that is the type of icon for this. So you'll see B simple is a type of Java class, and when we look at the subclasses, we'll see there's lots of different things that come from the B simple class, and B abs time is one of those. B rel time is another one. If I look at the B abs time help, then we'll see there's a decode from string method, and this is really what's being called by BQL to process a string, and it's going to create one of these objects, one of these B simple type objects based on the string format. So in this case, you can see for B abs time that it tells us it's the ISO 8601 standard, which is in the year, month, day, time, hour, minute, second, millisecond, and then the time zone offset. If we were to look at, say, Baja rel time as being another type of B simple, and we look at the decode from string, it just says read the simple from text format. So sometimes I end up going to the encode to string method, which is telling me how do I output one of these objects to a string. And in this case, it's telling me it's the number of milliseconds. So just take a look at decode from string or encode to string and see what it tells you there. All right, so jumping back in. With BQL, we can utilize any Java methods from a class, provided that the method's public, it returns a non-void value, meaning it has to give us an answer, and it doesn't take any parameters or arguments other than context. And what context is the session information. So when you're connected with the Workbench client or the browser to the station, there's some context that's implied there, meaning what's your username? What are your facet preferences? Do you prefer English or metric units? What kind of preferences do you have for how your date and time are displayed and things of that nature? What's your preferred language? English, Spanish, French, German, whatever language you prefer. All that information is carried in the context. So as long as the method only requires context, then we can utilize it. There's also a little bit of special handling here in that if a method starts with the letters get and something else, then by the BQL standard, we're supposed to drop those leading letters of get, and then the next letter is changed to a lowercase. And we always also drop the parameters, parentheses as well. What I'm trying to show here on this slide is that if I'm looking at the help for B abs time, we can see that there's a public method that gives us back a B weekday, and the name of that method is get weekday. Doesn't require any arguments or anything. So it's public, it gives me an answer, and it doesn't require any arguments. Looking at the Java method here in the table, you'll see how it says babstime.getWeekday, open close parentheses. So that would be if I was writing actual Java syntax. So for B format and BQL, they both follow the same rules. And in that case, we're going to drop that leading get in lowercase to W and get rid of the parentheses. So for B format, that just becomes %weekday %. In the BQL line there, you'll see that under the BQL statement, it says select timestamp.weekday. So you can take any Java method that's public that gives you an answer back, and it doesn't require an argument other than context, and we can use that with either B format or BQL in this case. Now, just show you again where I'm getting this from is if I look at B abs time here, BABS time, and we'll see the different methods that are available. You can see that there's this get weekday. Now, for example, this method is get weekday, but it asks me to provide it with a year, a month, and a day to test against. But if I am referring to this method of different signature, right? Same method name, but it has different parameters, so it's a different Java signature. Then this method can be called, in which case it just uses the current time of the station as the argument, and it tells me what the weekday is of the current day. Get year, kind of same kind of thing. I'm not having to pass in any kind of parameter or argument. If we look at something like a 2-times string, for example, this is public, gives me back a string, but it takes an argument. In this case, it's context, so I'm okay to utilize that method then. Show you a couple other examples in the PowerPoint here just to try to draw some emphasis. This is this, instead of looking directly at the help, I just have a few here that I've entered into slides. So in this case, you can see the method's public, but the return type is void. And even though the @steady_state method doesn't require any kind of argument or parameter, I still could not use that in BQL because it doesn't give me an answer back. In this case, I have a method that's public, gives me back a Boolean. Is parent legal is the name of the method, but it requires me to pass in a parameter or an argument. So in that case, because it's not context, I'm not able to use that method in BQL. This is another example of one which you can use. So this method is public. Final is just a keyword saying the developer doesn't want you to be able to extend or change the behavior of this Java method. It returns a string. The name of it is getDisplayName. And it requires an argument, but in this case, it only requires context. So in that case, I can use that method. Now, circling back a little bit more to the help, kind of wrap up here, and it'll be a good breaking point for our next video. When you look at the help, there's an option in the Baja docs to flatten inheritance. And when you flatten inheritance, that will show you all the inherited properties and methods, which can be a good way to look at Java methods that are available to be used with your BQL statements, but it can also be a little bit overwhelming as well at times. So what I mean by that is if I take a look at, say, B numeric point, for example, the numeric point class defines this out slot. So I'll see that there's a method called getOut for accessing that property. It's a public method that returns a status numeric. But I don't see anything about the proxy extension or the facets, and I know that a numeric point has those properties. Well, that's because those come from the ancestor, from the class that is extended from. And there's a couple ways that you can toggle this. One is to click on this icon here, which is flatten inheritance, or you can go up to Baja Docs and choose the flatten inheritance toggle here. What this does is now it's going to show me all the inherited methods and properties. So you'll notice that it adds a class name in front of each property with a dot character before the property name. So it's saying that this out slot comes from numeric point, but the facets property actually comes from the superclass from the B control point, and so does the proxy extension. You'll also see under the methods now that the method names here are all prefaced with a class, which is identifying which class does this method actually come from. And it does make the list a lot longer, for example, but if I come down to the get section now, you'll see that, for example, there's a get facets method that shows up in the help here, but it does tell me it comes from B control point. All right. If you don't want to flatten the inheritance, you can always look at what methods are available and then click the link to look at the superclass and then find the method maybe there that you're looking for, like get proxy extension or get facets or something of that nature. And this last slide is just trying to maybe draw a little bit of an analogy with something that's more familiar to you. I'm sure all of you use like %out.value % in your B format syntax on a PX view, or you use things like %name % or %get parent or %parent things of that nature. So where these come from is looking at the Java classes. So there's a Java class called B complex, which is a fairly abstract class in the framework that most things extend from. And at that high level is where the get name proper or get name method exists. So that's a public method, returns a string, and you drop the get lowercase the n, get rid of the parentheses. So that just becomes %name % in B format. Or when we're talking about BQL, it just becomes name. When we're talking about a numeric point, for example, there's a public method that gives me a status numeric back. It's called get out. So again, we would drop the get lowercase the o. And that's where we get the %out or just the out in the BQL statement. When you call that Java function, it will start with a numeric point. It gets the out slot as a status numeric. So then the dot character says, all right, I now have a status numeric, and I can call methods that are available on status numeric. So the get value method returns the double. That is just the value of that status numeric, excluding the status like OK or down or disabled. So hopefully that gives you at least the foundation into the BQL language and a little bit more about navigating the help, understanding the class system, and how to recognize which Java methods we can call with BQL. And those same rules also apply to B format. So stay tuned for the next video, and we'll get into the actual select statement, talking about the extent and the projection, and get into the predicates and all kinds of interesting information. So thanks for watching, and stay tuned for more.